Assalamualaikum. My name is Ain Izzati. My other three friends are Lily, Emilia, and Anis are going to present about our project, which are involving 3x3 matrices. So first, let's understand the question. We have a herb farmer who uses water on 3 types of herbs, which are basil, mint, and rosemary over 3 days. So, but here's the problem. We only know the total water used for each herb. We do not know how much water used for each day, from on day 1, day 2, and then day 3. We do not know that. So our goals here is to find the water used on day 1, day 2, and day 3. Now look at the table. From day 1 to day 3, basil used 6 liters, 3 liters, and 5 liters. Meanwhile, mint used 4 liters, 6 liters, and 2 liters. And lastly is rosemary used 2 liters, 1 liter, and 3 liters. So this number represents how much water used on each day. So the total given are basil 83 liters, mint 70 liters, and rosemary is 37 liters. So basically, my friends and I are going to explain on how to solve a system of equation using matrices 3x3. The first question, write the given information as a matrix equation of the form A times X is equal to B. So, matrix A is representing the coefficient from the table earlier, from the next slide. So, like from day 1 to day 3 are the matrix A. Meanwhile, matrix X is represent the unknowns. Water used on the day 1, day 2, day 3. The unknowns that we don't know that we are going to find later. And then, matrix B represent the total water used on each herbs. So, as we can see here, matrix A is 6, 3, 5, 4, 6, 2, 2, 1, 3. Meanwhile, X, let's say we label all these 3 herbs by X, Y, Z. And then, the lastly is matrix B, 83 liters, 70 liters, and 37 liters. But we do not include the liters, we just add on the number. The next step is to find the inverse matrix A. But why do we have to find the matrix A, the inverse matrix A? Because we have to find the unknown, which is the matrix X. So we have to find the matrix X by inversing the matrix A. But before that, we have to calculate the determinant A. So the determinant A is A in the bracket. So how do we find that? First, we have to look at the first number in the first line, which is 6. So, let's see 6, and we cover up vertically and horizontally same line as 6. So the number left is 6, 2, 1, 3. Then, we have to do the same technique with the number beside, which is 3. So we cover up vertically and horizontally same line as 3. So the number left is 4, 2, 2, 3. Same number beside 3, which is 5. Cover up vertically and horizontally 5. We got 4, 6, 2, 1. So now we have to do a cross multiplication. So 6 times 3 equals to 2 times 1 minus 3. Next, same as before, we have to do cross multiplication inside the bracket. 4 times 3 minus 2 times 2 plus 5 times 4 times 1 minus 6 times 2. So in total up, we got 32.
Now we will focus on calculating the minor of matrix A. As you can see on the screen, for a 3x3 matrix, we have 9 different positions to calculate, starting from M11 all the way to M33. Each of these represents a specific submatrix derived from our original values. To find each individual minor, we use the elimination method. For example, if we want to find M11, we must cut or remove all the numbers that share the same row and columns as that element. The 4 numbers that are not cut are the survivor are then placed into this smaller 2 by 2 matrix box. This systematic hide and seek ensure we isolate the correct value for our next step. Once we have our small matrix box, we solve them using the determinant formula A times D minus B times C. You might ask, why do we use minus? This is a mathematical rule to find the difference between the diagonal product. For M11, we take 2 times 2 minus 1 times 3, which equal 1. For M12, we take 4 times 2 minus 1 times 1, giving us 7. We repeat this process for all positions, carefully subtracting the product until we complete our entire minor matrix.
Let's move to the next phase. We have our minor matrix, but it's not a cofactor matrix yet. Step 1, we need to apply the cofactor signs pattern. This is a standard grid where we alternate plus and minus signs, starting with a plus at the top left. Step 2, we overlay this grid onto our minor matrix. Only the numbers in the minus position will change their signs. If it's positive, it's become negative. If it's negative, it's become positive. So step 3, creating the cofactor matrix. Look at the middle box. You will notice the sign have shift. For example, the 8 in the middle top changed to negative 8, and the 4 in the middle left changed to negative 4. Step 4, finding the adjoint A. The final step is to transpose our cofactor matrix. To do this, we simply swap the rows and columns. Row 1 become column 1, row 2 become column 2, and row 3 become column 3. This gives us our final adjoint matrix, which is the key to solving the inverse in the next slide.
Next, let's move on to my slide. To solve the herbs farmer watering schedule, our first major task is to find the inverse of our coefficient matrix A. We use the standard formula where the inverse is equal to 1 over determinant of A multiplied by the adjoint of A. As shown in the calculation, our determinant was found to be 32. By placing our adjoint values into the matrix and multiply each element by the fraction 1 over 32, we simplify the value. This gives us the final inverse matrix, which include elements like 1 over 2, negative 1 over 8, and negative 3 over 4. Now that we have the inverse matrix, we can apply the core formula for the matrix inversion method. X equal to inverse multiplied with B. Here, X represents the unknown daily water usage, and B represents the total water use for each herbs, which is 83 liters for basil, 70 liters for mint, and 37 liters for rosemary. We perform row by column multiplication. For the first row, we multiply 1 over 2 by 83 plus negative 1 over 8 multiplied with 70 plus negative 3 over 4 multiplied with 37. We repeat this process for each row to isolate our variables, which is x, y, and z. Once the arithmetic is complete, we arrive at our final matrix for x.
The result clearly shown that the variable correspond to x equal to 5, y equal to 6, and z equal to 7. In conclusion, by applying the matrix inversion method, we have successfully reconstructed the farmer's missing record. The result shows that 5 liters of water were used in day 1, 6 liters of water were used in day 2, and 7 liters of water were used in day 3. This method provides a way to ensure all 3 herbs types receive the exactly amount of water recorded in the final totals. That's all from us. Thank you.